Hello everyone, let's uncover the thought process behind my solution to the internal test. Think of this as a journey, starting with understanding the problem, navigating through challenges, and arriving at a solution that's not just correct but also as efficient. So I'll be breaking it down step by step, sharing key insights and highlighting the strategies that met the differences. So let's dive into the solutions and explore how it all come together. So we will start from the question number first, that is how. So we will see our question number one is how is unstructured data analyzed. So before that, what do you mean by the unstructured data? Unstructured data that refers to the data that doesn't conform to a predefined data model, such as the text, images, audio, or videos. So analyzing such data involves transforming it into a structured or the semi-structured form to extract its meaningful insight. Now there are some steps that how one can analyze the unstructured data. So first step is, just a second. Our first step is data collection. Data collection is like gather raw structured data. The example, customer review, emails, social media posts. Second is data pre-processing. What is data pre-processing? Clean and analyze the normalize the data. After that text, first of all you should remove the punctuations and stop words, lowercase conversions, stemming, and lemmatization. Now, for the images, you should resize the images, filter the noises, and enhance its clarity. And for the audio, you should convert speech to a text. After that, feature extraction. What do you mean by the feature extraction? It is basically to convert unstructured data into structured form using the appropriate techniques. Okay. Now, what is the text like TF, IDF, word to VC or BERT embeddings for the images, feature vector using CNNs, and audio for spectrograms or MFCCS. Now for the pattern discovery, apply machine learning ML and the natural language processing, that is the NLP or the deep learning techniques. After that, pattern discovery. In the pattern discovery you can also see text, like you have to sentiment analysis, you have to perform topic modeling, entity extractions, and for the images you should like object, you have to detect the objects, you have to classify it. For the audio you should speech recognition, you should done the speech recognition, sentiment detection. Last step to analyze the unstructured data is the interpretation. For the interpretation, one should visualize or summarize insights using dashboards, graphs, or the reports. Now we will discuss the second question, which is how text mining techniques can automate the process of classifying written complaint. So automating complaints classification using text mining techniques. Now what is the text mining? Text mining techniques can help automate the classification of the written complaints by transforming unstructured text into data, structured formats, and using machine learning or the rule-based approaches to categorize them. Now, what are the steps to automate the complaint classification? So, for that, there are some steps. First is the data collection. You have to collect the data from the various sources like emails, forms, or the customer support logs. After the data pre-processing. So, in data pre-processing, there are other sub steps which are like first text cleaning. So you have to remove noise such as the special characters, HTML text. After that, lowercasing, like standardized text by converting it into the lowercase. Then after that, the next step is that you have to remove the stop word, okay, which are like eliminate common but irrelevant words, like the end is like sort of the grammatical words. After that, tokenization. So what is the tokenization? Tokenization is basically split text into the individual words or the phrases. Okay, and after that your next step will be like lemmatization or the stemming, which is like reduce words to their root forms. Like if example, if the word is delayed, then you should convert that word into delay. If the word is stolen, then you should convert that word into the stole. So here is the code of the pre-processing. So it's a Python code. Okay. of the pre-processing. After that, okay, so here we can see that the tokenization is done, okay, lemmatization is done, and stop words are also removed. After the feature abstractions, in the feature abstraction, the first topic is bag of words. So bag of words is BOW, which represent text as a count of the words. Okay, after that, TF or IDF. So TF is term frequency, inverse document frequency, where terms based on the frequency and the importance. After that, embeddings used pre-trained models like what to be, was, Glowy or the bird for semantic understanding. Again, here is an example code of the TF IDF, that is a term frequency, inverse document frequency. So you can see here. After that, the next step is model selection. In the model selection, choose a classification algorithm which depends on the complexity and the size of your data. Now, as we discussed, Naive Bayes, that is a simple and effective for the small data sets. Second is support vector machine like SVM, that performs well on the text classification task. So you can also prefer support vector machine. After that, deep learning, use models like RNNs, LSTM, or the transformers. Transformer is here is one example of transformer, that is BERT for complex data set, that is a BERT. Okay, again here is a example code of the naive Bayes classifier. So you can see here. After that, the next step is automation workflow. For the automation workflow, first is pipeline. So create an end-to-end pipeline that includes pre-processing, feature extraction, and the model inference. Okay, now after that we can see here. Next step will be deploy the pipeline as a service to process new complaints in the real time. Next step is evaluation. Use label complaints to test the model and evaluate matrices such as the accuracy, precision, recall, and F1 score, which is we already discussed in our data science series. After that, advanced techniques for the automation is multi-level classification. Like complaints can belong to multiple categories. For example, delivery delayed and product damage. If this is a text, then here is the delivery issue, and also here is a product quality issue. So use algorithm like logistic regression with one versus rest, or deep learning models like BERT. After the topic modeling for unsupervised classification. So if the categories are unknown, use topic modeling techniques like LDA to discover complaint themes. After that, entity recognition and rule based system. For that, combine new entity named entity recognition, that is the NER, to identity keywords like the delivery, delay, okay, with a rule based system for the classification. Now we will see what are the benefits of automating complaint classification. For that, first is efficiency, which reduces the manual efforts and the processing time. After that is scalability, that is the handles a large volume of complaints. And third benefit of automatic complaint classification is consistency, which ensures uniform classification standards. By leveraging these techniques, you can automate the classification of the written complaints with a high accuracy and the reliability. Now we will discuss the question 3, which says consider the following complaints, such as the approach, algorithms, process to identify applicable IPCs, RNS, sections to recommend applicable BNS, that is the broad national categories sections of the IPC, that is Indian Penal Code sections. So here the complaint is theft of the mobile phone by an unknown person at the MG Road on 2023 of February. Okay, and the date was 20, and the phone was stolen. Okay, the phone was stolen here. Okay, the phone was stolen when was shopping at a store, and the thief was wearing a black jacket and a scar on his face. Now, approach to identify applicable IPC's RNS section for this complaint. Okay, first of all, that is a complaint text. Now write your complaint text fully, that is a theft of the mobile phone by an unknown person at the MG road and its timing, and after that the phone was stolen and where the phone was stolen and what the thief was wearing. After that first step will be pre-processing the text. So pre-process the complaint to extract essential elements like steps. First convert to lowercase. First convert your whole complaint into the lowercase and remove the punctuation and the stop words. Then tokenize and lematize the words. Tokenize like to break your whole complaint into some sort of the small text. Okay. After they use named entity recognition, that is the NER for the structured data extractions. After the next step will be key abstract elements, like extract the key elements like crime, then it will fall under the theft. Okay, here we can see that theft of my mobile phone. So what the word theft? So theft word is falling under the category of the crime. Again, mobile phone is falling under the category of the object stolen. After that the location is given in the complaint and the date was given. Then the details of the thief, that is the detail of the thief was given like that, wearing a black jacket and had a scar on the face. Okay, then first of all the next step will be like feature engineering. So convert your whole complaint into a format suitable for the machine learning or the rule based analysis. So first is structured features like crime type. What was the crime type? Theft. Keywords like theft. Then identify some keywords like theft, stolen, mobile. Then again identify the named entities, which is a date, location and the object. Then use the techniques. What kind of the techniques you can use? Like you can use TF IDF, which you already discussed, and embeddings for the textual representation. Next step will be algorithm selection and the process. So approach one is rule based mapping. So create a keyword. Okay, first of all the step will be create a keyword to section mapping using a domain knowledge of IPS or BNS. Okay, first of all you should have a domain knowledge of the IPC sections and the BNS sections. So for example, for the theft, IPC section 378 is there, and the mobile phone theft subcategory, it's a subcategory of the IPC section 378 will be applied over it. Okay, then just apply in the Python code. We have written the whatever IPC sections will be applied. So we have written a code over here. Okay, we have created a function that is a classify complaint, and over there we have also written theft, and it fall under the category of the and it will fall under the category of 378 IPC section, and stolen will also fall under 378 IPC section, and mobile phone theft will also fall under the subcategory of IPC section 378. After that, approach 2, that is a machine learning. Dataset preparation. Collect all the labeled complaints with their corresponding IPC BNS sections, and after that model selection. Train a text classification model such as the logistic regression. So logistic regression is basically for the simple classification. Then the random forest. So random forest is for the multi-level classification, and after that BERT, that is used for the semantic understanding of complex complaints. After that there will be the next step, which is the implementation. So implementation is a use pre-trained BERT embedding for the text classification. Next will be workflow to identify IPC BNS section. So first is NER for extraction. First of all you should extract the crime type, objects and location. After the semantic understanding, like use embeddings like BERT to match complaint with the legal sections. Then classification model. In the classification model, train a supervised model on the label data to recommend appropriate sections. After that validation. So validation is like use cross validation to assess your performance. After that the next step will be applicable IPC sections for the complaint. So you should apply the applicable IPC sections for the complaint. Okay, IPC section 378. Whoever dishonestly takes any movable property out of the possession of any person without their consent, then IPC section 378 will be applied. Then possible broad national category, that is a BNS section. So BNS section 101 will be applied on for the theft related offenses. After that matrices to evaluate the system. First is the precision. So what is the precision? Precision is like the percentage of the correctly identified sections among all recommended sections, and after that recall, which is the percentage of the applicable sections correctly identified by the system. And next is F1 score, which is a harmonic mean of precision and recall. After that, confusion matrix, which analyze true positive, false positive, and the false negatives. So by following this approach, the system can recommend IPC or the BNS sections for a given complaint with accuracy and consistency. Now we will discuss the next question, which is suggest suitable data structure and algorithms for the question 3. So what was our question 3? Our question 3 was related to some sort of the complaint. So I will repeat the question again. Consider the following complaint suggest the approach algorithm process to identify applicable IPCs, sections to recommend applicables BNS and the IPC sections. So for that we have to apply now the suitable data structure and algorithm. So first of all, to identify applicable IPC BNS section from the complaint, we need to choose data structure and algorithms that enable efficient processing, analysis, and the classification of the textual data. So here first is like um, text representation. In the text representation, first is bag of word, that is BOW, which represent text as a vector of the word counts. After that, TF-IDF matrix, which weight terms based on the frequency and importance. After that, third is embeddings, use dense vector representation for the semantic understanding. Next will be dictionary and the hash map, like store mappings between keywords and the IPC BNS section. Example, if our theft, if a word is theft is there in a complaint, then we will use IPC 378. If a stolen is if any object is stolen, object is stolen, then we will use obviously IPC 378. Now prefix tree, create a prefix tree, like store keywords for the fast matching. Example, used to match phrases like mobile phone theft. Okay. After that, graph, so create a graph like represent a relationship between entities, like example crime tab. Then if example if crime tab is an entity, then create a relationship with it with for the with applicable sections. After that, we will apply an algorithm. For the algorithm, that is first will be rule based mapping. So use keyword matching. Okay, so use keyword matching to map complaints to predefined sections. After the text classification, classify your text. So first is supervised machine learning. So in that, logistic regression, naive Bayes, whatever suitable model will be there, you have to apply it. After the deep learning, so in the deep learning there is a BERT or LSTM. So for semantic understanding of complex complaint, use BERT or the LSTM. After the name entity recognition, that is the NER. So use NER algorithms to extract entities such as crime type, date, and location. After that, similarity algorithms. So use cosine similarity to compare the complaint text with the descriptions of the IPC BNS section. Example, match complaint embedding with the computed embeddings of the legal sections. After the multi-level classification, so for the multi-level classification, handle cases where the complaint may map to multiple sections, like example, random forest with a multi-level support, or the BERT with a multi-level classification. Now the next question which we will going to discuss is question number 5 of the internal one, that says suitable matrices for assessing performance in the text mining. So basically it's an evaluation of your question number 3. First is precision and recall, which we already discussed matrices in our data science series. So first is precision and recall. So evaluate how often the correct IPS or the BNS sections are identified. Second is confusion matrix. Analyze cases where the model misclassifies or misses certain sections. After that, error analysis. So in error analysis, basically you have to analyze your errors. So checks for the patterns in the misclassification. Example, if robbery is a mistaken for the theft, by using this matrices, the performance of the algorithm can be rigorously assessed and optimized for the better accuracy and reliability in the text mining tasks.